Hi everyone, welcome to Python Osmosis, episode 35, the screencast that allows you to divide by zero. I'm Ryan Shea, and in this episode we'll be talking about more on errors and exceptions. So I've pre-written up some of this code here to speed things up. I've created a file list with two files in it, foo and bar, these are just strings, and then a loop that's going to go through that list, pulling out the file name. And I have a try. And I'm going to try and open each of those with read permissions, and I'm going to catch an exception if there's an IO error. Now in this case, neither the file foo nor bar exists, so that's what's going to be caught. And I'm going to print a custom message where I say cannot open, and I'm going to print out the name of the file. Something new here is the else clause. With a try and except, you can also have an else. If the try completed without any exception being raised, then the else is called. So this is a good way to print out some additional information, or basically you want to limit what's in your try, because if you have a whole bunch of different operations in your try clause, then you aren't sure which piece of that actually raised the exception that you're trying to handle. So you want to keep that as small as possible and then put your additional code into an else clause. So in this case we've taken and printed out what the length of the number of lines of the file is. So we used f.readLines, pulled out that length and printed that out, and went ahead and closed the file. Actually it should be like that. So as I said, in this case, we don't have either foo or bar, so we'll see cannot open foo, cannot open bar. So it wasn't a fatal error. It printed out cannot open on both of those, and we know exactly what happened. So that's what happens if you want to, the condition where no exception is raised, you can use else. You can actually, as we saw a little bit before, we can manually raise an error. So raise name error. Hi there. And you see that's exactly what was raised. We see the built-in name error type, and we passed to it hi there, and the string was passed right along with it. So we can manually call any of those built-in types of exceptions. Let's do another one. Try. We're going to raise hi there. We're going to turn right around and catch that name error. An exception flew by. And then we can actually re-raise the error, printing out exactly what would have been printed before we manipulated and put in our print. So let's take a look. So again, we manually raised a name error with hi there. We caught it with except. We printed out a line, an exception flew by. And then we just re-raised that error. So it did exactly what it would have done had we not put in that first print statement. So this will let you allow the built-in error or the built-in exception to do its own thing, but you can put in some additional code in there. You can also create your own types of exceptions. So let's take a look at that. I know we haven't talked about classes yet, but this will be an example. An exception is a class. So let's make one. And what this means is we're going to create a new class called myError, and it's going to inherit from exception, built-in type. And we're going to override what's called the constructor, which is underscore underscore init underscore underscore, and self you'll always have to put. And this constructor, what it's going to do, it's just going to set the value attribute equals value. So whatever we pass into it is going to be set to the attribute value. instead of, I believe args is what by default would go when you raise an exception and you pass in. So for example, like on this, hi there was by default sent to args. And then we're going to, you know how we've talked about repr and stir. There's a underscore underscore stir method of a class, and that's what happens. That's what's called when you do things like print. It treats it as a string and returns what you'd want for printing. So in this case, it's similar to repr. So we're going to use the repr function on self.value, which is whatever you pass into it, a string or a list, and we're going to return that. So when you print this particular error class, it's going to just return what was in value. So now we have a class. Oh, forgot, not in IPython. So now we have a class called myError that we see right here. And I could say type myError, and it's of type. Not very useful. So let's go ahead and use it. Try. And we're going to manually raise this exception, myError, and we're going to pass into it 2 times 2. We're going to catch that with an accept as E. So remember, what that's going to do is we're going to capture in E the class instance of myError, and then we can manipulate it from there. Print my exception. Let's do occurred value, and then we're going to print out what the value is, e.value. So that class instance, we're going to pull the value attribute, which we were setting with the constructor right here. We're going to print that out. And we could have actually just printed out E, because E would have returned the same thing. It would have returned the repr of the value. So there we go. My exception occurred, value 4, which is, yes, 2 times 2. It got set to value, and then it got returned by us specifically calling that instance attribute of value. So I mean, you can use this to handle any kind of exception for whatever custom program you're building, and handle it a little bit more smartly and extend beyond the built-in. So let's take a look at cleanup actions. So let's force an exception. We're going to raise a keyboard interrupt, and we're going to do what's a finally. We haven't seen this before. Goodbye world. Okay, so we saw what happens when we have a try, accept, another accept, and then an else. An else happened when no exception was raised. In this case, finally is going to be called regardless of whether an exception was raised. So we are forcing a keyboard interrupt to be raised, but we're going to see that even though that exception was raised, the finally clause is still going to be called. We're still going to see print hello world. So let's take a look. I'm sorry, not hello world, goodbye world, and then there's it re-raises the exception. It re-raises the keyboard interrupt. So this is useful if you have some kind of cleanup action that needs to take place. So for instance, if there's a multi-stage process that puts pieces into a database, and then if at the last stage it fails, there's a cleanup action, and you raise a custom exception, and there's a cleanup action of, oh, we'll get rid of all of those little bits the mess that I created along the way, you can put that in a finally condition, and that'll go ahead and clean up what you need. So let's look at a more comprehensive example that puts all these pieces together. So we're going to create a definition here. Divide x comma y. And in here we're going to have a try. And we're going to say SULT equals x divided by y. Now, of course, we know the problem that can happen here. So we're smart, we're going to handle that. Division by 0, and just print that out to the screen. Else, again, this is else if no exception was raised, then run the else clause. Result is, and that result variable. Finally, regardless of whether or not an exception was raised, now this is of limited usefulness, but at least it shows us what happens. So let's call this function divide 2 comma 1. Result is 2, executing finally clause. Okay, so no exception was raised, and we see the finally clause. Divide 2 comma 0. Let's make sure an exception is raised. Division by 0, executing finally clause. Let's do another one. Let's do a string 2 by the string 1. And we have a type error that was raised, but you see it re-raised that type error after it ran the finally clause. So executing finally clause, and then we see the type error. Now some things will clean up by default, and this is just, we've mentioned this before, but just to go through again, let's say we created a loop for line in open myfile.txt. So open the myfile.txt with read permissions and loop through each line. Print line. Now there is no myfile.txt, so we got an IO error, but the thing is we opened up a handle, an unnamed handle for myfile.txt, and we just sort of left that open indefinitely. When this exception was raised, we didn't clean anything up. We didn't close that file handle. So the right way to do this is with the with keyword. With open myfile.txt as f for line in f, print line. Okay, we have an IO error, but if basically f is a closed file handle now. With made sure that there was a built-in cleanup action that took place that automatically closed that file handle. So this is probably the syntax you want to remember for opening up and looping through file handles, as opposed to inline sort of just opening up a file handle and looping through it. That's all for now. This screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.